This is a thermochemistry stoichiometry problem. How much heat is released when 155 grams of ammonia is allowed to react with excess oxygen, as shown in the equation below. Okay, so you see we have this chemical equation and then followed by delta H of reaction. Okay, so this is now we have an actual part for this chemical equation. Okay, and you can consider this heat that's with a negative sign, which means it releases heat. So that should be one of the products of this chemical reaction. So if the reaction releases heat, of course, we also call that exothermic process or exothermic reaction. Okay, so let's develop our strategy. Okay. Now, if you look at this cartoon, I added heat to it because now, as I just mentioned, heat can be considered as one of the products of a chemical reaction. Okay, so now what do we know? We know the mass of ammonia. We can consider ammonia as A. Okay, so mass of ammonia, and then what do we need to find out? We need to find out how much heat is released. Okay, so we need to start from mass of ammonia. So we don't need to consider B in this case because we have excess oxygen. So therefore, we just need to use this part of this cartoon drawing. Okay, so we start from mass of ammonia, convert that to number of moles of ammonia, then from the number of moles of ammonia to the heat released. Okay, so that's what we are going to do. Okay, so the heat release, we start from what do we know? Mass of ammonia, change that to moles. Dimensional analysis we have been doing for quite a while. And then how to convert from moles of ammonia to the heat, we have to use this delta H of reaction. Okay, now you need to understand the balance equation. In this balance equation, 4 moles of ammonia reacts with excess oxygen, forms 4 moles of nitrogen monoxide and 6 moles of water, and releases 906 kilojoules of heat. Another way you can interpret this reaction is 5 moles of oxygen reacts with excess of ammonia, forms 4 moles of NO, 6 moles of water, then releases 906 kilojoules of heat. Or you can say you have enough ammonia and oxygen, and then after the reaction there are 4 moles of nitrogen monoxide and 6 moles of water and 906 kilojoules of heat. You see? So therefore now the question is, what kind of conversion factor should we use? We know in the previous calculations in stoichiometry, we use the coefficients in the balance equation. Here, we use the coefficient in the balance equation as well as delta H of reaction. So therefore, convert from moles of ammonia placed on bottom, to heat, kilojoules on top. And then the coefficient, then the conversion factor right here, ammonia, we take the coefficient 4 moles. And then for the heat, we just use that delta H of reaction. And don't forget the sign. Don't forget the sign. Okay, that's it. So now you can see ammonia, moles of ammonia are gone. Of course, grams of ammonia, they are also gone in the previous calculation. We should just have kilojoules. Okay, so as a unit for the answer. Okay, and you have to carry the negative sign, and the negative sign means heat is released. So therefore, after taking care of the sig figs, we know there are 2060 kilojoules of heat is released. Okay? So now you may say, oh yeah, I can't draw this cartoon, on test. It's just too complicated. Can you help me, to find out the easier ways, so to come up with a strategy you just did a while ago? Means I just did a while ago. Yeah, I mean, so you can do this. You can, draw as 2 classes, okay? 2 cross sign. On the left-hand side is A, right-hand side is B. Again, in this question, we just stay with A, is that right? We didn't do anything with B. But in most cases, in stoichiometry, you do need to. So therefore, I want you to learn this 4 depiction right here. Okay, then here, that's mass. See, that's mass. And then on top, that's heat. Then on bottom, that's just number of particles, can be atoms, can be molecules, ions, and so on and so forth. All right, and the same thing for B. All right, and then if it involves conversion between 2 substances, of course, so here either you use a subscript or you use a coefficient in a balance equation. All right, and you may say, oh, this deal kind of not easy to draw. Then just simply draw 3 lines. 1 line, 2 lines, 3 lines, and make sure the left-hand side is A, right-hand side is B, and right here, that should be moles. So moles of A, moles of B, then that should help you. Okay, here Q, that's just heat, and G, that's mass. Don't be confused. Hopefully, this would be helpful. It just takes a few seconds to draw this.